Hi guys, welcome back to my channel Pirai Academy. In this video, we are going to see about a Leetcode question number 1911, maximum alternating subsequence sum. The alternating sum of a zero-indexed array is defined as the sum of the elements at even indices minus the sum of the element at odd indices. For example, the alternating sum of 4253 is, I want to take 4 and 5 because they both are what? They both are even indices, right? So I'll be taking the 4 and 5 and doing a minus operation with 2 and 3. Hope you understand this. So that's why we will be getting 4 as our output. Okay. Given an array nums, return the maximum alternating sum of any sequence of nums after reindexing the elements of the subsequence. Okay. A subsequence of an array is a new array generated from original array by deleting some elements, okay, possibly none, without changing the remaining elements relative order. Okay, for example, 274 is a subsequence of this particular array, while 242 is not a subsequence because here comes 2, then here comes 2, at last only there is a 4, right, and at first only there is a 4, no 4 in between the 2 and 2, right? That's the reason why it is not a subsequence. Hope you understand the problem statement, right? And many of them will not understand the problem statement at this particular point. Let me explain this now. Just see here. If this is the array, this is the array, and let me take this as a subsequence also, because subsequence can be also the entire array, right? Now, what are the even indices? So this 0 and this 2 are the even indices. So do the plus operation. Now, what are the odd indices? This 2 and this 3 are the odd indices. So do minus 2 minus 3 is equal to 4. So this is the reason why we are getting the 4 for this particular subsequence. Okay. Now get back here. So see here, nums is equal to 4253. For this particular array, what is the optimized value I will be getting? I will be only taking the subsequence as 4, 2 and 5. I'll be taking only 4, 2 and 5 such a way that I'll be taking 4 plus 5 minus 2. Can you understand this? Fine. So see here in the next problem, in the next example, it is 5, 6, 7, 8. Here I'll be taking only 8 alone. Okay. Meanwhile, here in this particular array, I'll be taking 6, 1 and 5. Okay. To get the maximum alternating subsequence sum. Fine. Okay. So how we are going to deal this problem? So see here, it is the basic understanding is we want to first try with the greedy approach, but greedy approach fails here. Why the greedy approach fails here? Because see here, it is not picking the maximum value and the minimum value. It is picking a subsequence. Whenever it is picking a subsequence, you want to go for recursion, all possible combination. So that's called the recursion. Okay. So what we are going to do in a recursion? Fine. Let me just save this. Just a minute. Fine. Now what we are going to do in a recursion? The first step in the recursion is always defining the function, right? So how my function something looks like. So function will be having, first of all, I want what is the current index, right? So I want to traverse among the array. So I want the current index. So take current index as I. Okay. What are the remaining details I want? I want to know either I am standing at the new index of even or odd. Can you understand this? See here, this is the array. This is the array. We can generate n number of subsequence, right? This is one of the subsequence. This is one of the subsequence. This is one of the subsequence, right? So what is my core understanding is, when I am starting from this 2, this 5 should be subtracted here, right? When I started from this 4, this 5 should be subtracted. Likewise, we want a flag variable. We want a flag variable. Why we want a flag variable? Because we want to make sure whether I want to subtract my current element or whether I want to add my current element. Can you understand this? Always remember, whenever the problem statement is about the maximum sum, then you don't want to care about the subsequence. You always care about the sum. Okay, that's the important step here. Okay, now first of all, I want to start from 0th index and let me take the flag as 1. 1 means positive, and 0 means negative. Let us take like that fashion. Okay, Now see here, this is the given array, right? Now before getting into this, if you don't know about the recursion and backtracking, I'll be giving the video link in the description. Just go and watch how we are going to construct the recursion and how the recursion stack is working and how to build the recursion tree and how the recursion works in a DFS manner. Then come and play back this video. Okay, because here I am not going to finish the entire recursion tree. I will be completing a part of it. Okay, to know about that clearly, just go and watch that video. Okay, fine. Now I am starting at this in this number 0. Okay, so here I have two choices. Either I can include that in my subsequence, or I don't want to include that in my subsequence. Can you understand this? Okay, okay. If I want to include it in my subsequence, what should I think at first? So see here, what is the flag value? It is 1. 1 means what? It is a positive. So which means 4 plus I want to go to the next index and make it a 0, because I have took this 4. Which means in next step I want to take the next value as a minus value. Now I have taken plus 4. In next value it should be minus. That's the reason why I am just changing the flag value into 0 again. Okay, fine. Now I don't want to not take. If I not take, what should be the next recursion call? It is like I will be going to the first index, but I'll be not changing the flag value. Can you understand this? Right? Now, what is the next step? From here, again I can either take or not take. If I take, it will be something like, what is that particular value? So it is 2, right? So flag value is 0, which means minus 2. So minus 2 plus f of, go to the next index and change the flag value as 1. Okay. Now here it will be like f of 2 comma 0 itself, right? Okay. Now here again 1 comma 1, which means this 2. So I'll be taking this 2 alone plus f of 2 comma 0, or else what should I do? I'll be just going to the next thing, not take. Okay, I just go to the next thing and keep the flag value as it is. Okay, fine. Now again here also I have take and not take. If I take, what is the second in this value? It is 5. Okay, now in this 5 I want to take as positive or negative. I want to take it as a positive because flag value is 1. So take it as a positive. So 5 plus f of 3 comma 0. If I not take, then what should I do? I just go to the next value. Okay, and keep the flag as it is. Fine. So let me finish this first so that you can understand this clearly. Okay, now again I can take or I can not take. If I take, what it will be? So 3 comma 0. 3 comma 0 means, what it means, at this particular third index I want to take it as a negative value. If I take it as a negative value, minus 3 plus f of 4 comma 1. Okay, if I don't take it, it will be f of 4 comma 0. Okay, now I want you to understand now clearly. See here, it is what? F of 4 comma 1. Whether the fourth index exists? No. At this point, what should I make this as? 0. Okay, here also fourth index doesn't exist, so make this as 0. So from here it is returning minus 3. From here it is returning 0. What should I take? What is asked in the question? In question they are asking us the maximum value. So take the maximum value. What is the maximum value? It is 0 only. So instead of this, I want to replace as 0. Okay, now 5 plus 0 will be 5. So 5 is returned here. Similarly, for this recursion also, finish this recursion entirely and something returned here also. So what my core intention in this recursion is, listen this carefully. First of all, I want f of I comma flag. Okay, now I have two choices. I can either take or not take with respect to the flag value. If the flag value is equal to 0, then I want to take as a negative or I want to take as a positive. That's it. So it is basically like nums is the array, okay, nums of I plus I want to take the go to the next index, but the flag value should be changed, so I must toggle it, okay. So here the plus or minus will be judged by this flag value. Can you understand this? Now if I not take, it will be something like f of I plus 1 comma just flag value, that's it. Can you understand this? So this is what the recursion call and recursion function we want to do. Fine. Now tell me, what's the time complexity? Time complexity will be O of 2 power n, and space complexity will be O of n. Why the time complexity is 2 power n, space complexity is O of n? Because 2 power n is because for one recursion we are splitting into two things. So for n recursion it will be 2 power n. And why this space complexity arises? Because of the internal stack we used. Can I understand this? Fine. Now let me show you the code so that you can understand this clearly. Then we can go and optimize it. Okay. So here I have written the Python code. If you want Java or C++, just go and find in the description. Okay. Fine. Now this is my another function. Okay. Recursion function. So in this recursion function, I am using I and flag, as you know already. Now what is the base condition? I have already told you. So whenever my index reaches the end, okay, then I want to return 0. So this is the only base condition I have told you, right? Now if flag is equal to 0, then what should I do? Else what should I do? So these are the two conditions I also told you, right? So if flag is equal to 0, then I want to return what is the maximum among take and not take. Take means what? Take means minus my current element plus I want to go to the next index and toggle the flag value. Else I want to go to the next index alone. Don't do any modification. Similarly for the else part also. Okay. The only difference you can see here is here it is minus and here it is plus. That's it. Okay. At last, what should I return? I should be returning the function call of 0, 1. That's it. Can you understand this? So this is a recursion function and it is purely a brute force approach also, and it's surely not going to be executed successfully because here they are already told you that it is 10 power 5. What is meant by 10 power 5? Which means we can run a program of time complexity n or n log n. It won't allow us to run either a n square, but this particular program is 2 power n. Then how come it execute, right? So let us optimize it. So the next method we are getting into is memoization. Okay, so if you already saw my DP series, then you can understand what is memoization. Whomsoever didn't saw my DP series, just watch it. You can understand what is memoization. So step 2, memoization. So memoization is like whenever I compute some value, I will storing in my memory. When that particular problem is again occurred, I will go and give the solution for it, which I already stored. Like, see here, what is recursion? Recursion is always breaking down the problem into subproblem, such that the minute problem can be solved by itself, and using that problem solution, we can find the solution for the main problem. Similarly, in memoization also, see here, some problems like here it is f of 2, 0, and here it is f of 2, 1. Similarly, it is also repeating anywhere else in the recursion call, in a recursion tree. So whenever it is again repeating, if you complete this recursion tree, then here also it will be going like this. Here also it will be going like this for the recursion calls, right? So which means it reduces our time, it reduces our speed of execution. So that's the reason why my suggestion is, whenever we are using a memoization, we are storing this particular value in my memory such that whenever it is again occurring, instead of going for all these recursion calls, I will be just bringing out from my memory and giving the solution here. Same problem, so I will be giving the solution here, so right? Okay, fine. So this is what the memoization technique means. So here we want to do 3 steps for the construction of the array. Okay, so we can do this using hash map, or we can use array. Okay, fine. So hash map approach is quite easy approach. So after watching my array approach, try the hash map approach by yourself. I want you to try out it. Okay. But however, array approach gives you advantage of further optimization. But in hash map, you don't have much optimization techniques like array, and also it consumes more time. Okay, fine. So in array approach, first of all, we want to design the array. Okay, first of all, we want to build what is a dimension. So what is the dimension of the array? So what are the varying parameters we have? There are two varying parameters. One is I, another one is flag. So we have two varying parameters. So we are going to construct 2D array. Okay. What are going to be the size of these arrays? So this I value will be starting from 0 and reaching up to what? Reaching up to the length -1. This means n minus 1. Okay, fine. Similarly, flag value will be reaching from where? Either 0 or 1. Okay, so from these two things, I can construct my array like this is my array. If the given input array n size is 4, then I have 4 rows. But only 2 columns. So this is because of the flag variable, and this is because of the n value. Can you understand now how I constructed this array? Okay, now what is the next step? Next step is I want to set some default values. Like, see here, what value will not be repeated here? So I want to just check out it. So here I don't have any values like -infinity or +infinity. Okay, or I don't have any values like null. Can you understand this? So you can keep all these values. So I can make all these values as infinity. That's fine because infinity not going to occur. That's the key point. You want to assign some value which not going to be occurred in the return statement. So infinity is not going to be occurred there. So I'll be making this as infinity. Fine. What is it? We have still 2 remaining steps. This is the first step, the array construction. The next step is we want to add one line here, one base condition here. So the base condition is if my let us take this as dp. Okay, if my dp of the particular index I and flag, okay, is not equal to infinity, then I want to return that particular index value because it is already computed. Why should I again go for the body? Can you understand this? Okay, again in this return statement I want to modify one line. In this return statement again I want to modify one line, like dp of I and flag is equal to recursion call of, sorry, not here, sorry, just a minute, not here, at these 2 points, at this point and at this point. So at these 2 points I want to do like, I want to store that result in my index, then I want to return it. Like in dp of I and flag, I want to store it first. So store this entire line, like maximum among all these stuffs. Okay, then return it. Similarly, do here also. Okay, I will be showing this in code clearly. Okay, so these are the 3 steps we want to do such a way that the code is memoized. Now tell me, what is the time complexity? So time complexity will be hugely reduced to, see here, observe this carefully, the time complexity is reduced to n. Okay, and space complexity will be over n. Okay, so this is what the time and space complexity. Why I am putting the space complexity as n? See here, it is n cross 2. It is n cross 2 matrix, which is almost equal to n only. That's the reason why I am putting here n. Okay, similarly the time complexity is also reduced to O of n. So this is going to be your code for the memoization. So see here, everything will be remain same. Except see here, I have initialized some matrix called, here it is catchy. You can also initialize as dp, that's your wish. Now here I used n cross 2 matrix. Okay, and initialized everything as infinity. And here I want to add 2 lines. Okay, I want to check whether it is already computed. If it is already computed, I just return it. Okay, and before returning it, I want to store it in my array or matrix, then only I want to return it. Similarly, here also these two lines. Can you understand this? Okay, so this is what the entire memorization code, but still it gets submitted successfully, but still we can still optimize it. Okay, we can still optimize it. Let me take this. So the next optimization technique is tabulation. So I recommend you to watch my entire DP series, because if you watch entire DP series, you can solve a DP question by some practice. Okay, so see here, the third method is tabulation. So what is mere tabulation? So see here, before getting into a tabulation, I want to show you why we are using the tabulation method. So here the space complexity is because of what? Because of two things. One is because of the matrix we have initialized. Another one is because of the recursion stack. So first let us eliminate this recursion stack. How we are going to eliminate the recursion stack? We don't want to use the recursion. If I don't want to use the recursion, I'll be using a looping. Okay, so how we are going to change this code into a tabulated code? So here also you want to follow some set of rules. Okay, now what is my dimension of the array? So DP array dimension is n cross 2, hats of note, right? Okay. Now I want to check the base condition also. So what is the base condition here? The base condition is if my index is equal to the length of the nums, which means if my input size n is 4, okay, then as usual my DP array will be having what? 0, 1, 2 and 3 and two columns. But now I also require this 4 also. So I'll be adding one more row. Which means here I will be using n plus 1 cross 2. So the DP dimension will be n plus 1 cross 2. Can you understand this? So this is going to be your modified array or modified matrix. Okay, what is the next step I want to do? Just eliminate these two lines. Okay. Now rest of these lines are body of my recursion. Whenever I reach the body of the recursion, put a for loop. Okay, for. So what is the first varying parameter? It is I, right? So for I, so I should be ranges from where to where? It is ranging from 0 and going up to what? N is the base condition. So it is going up to n minus 1. It will not go to the n. It will be going up to n minus 1. Okay. So I is from where to where? 0 up to n minus 1. Put in a reverse format, which means n minus 1 up to 0. Can you understand this? So it is a simple step. Okay. Now what's the next varying parameter? So it is a flag value. So flag. So it is also, you should put in a reverse fashion. So here it is 1. Then next it will be going to 0. Then again it will be 1. Then again it will be 0. So here also you can use any format. So here I am going to use like starting from 0 and going up to 1. Okay, so only two iterations, 0 and 1, 0 and 1, 0 and like that for the flag value. Okay. Now I forgot to tell you, here everything is infinity, right? Here everything is infinity in our memorization technique. But now I want to change this, like for this particular 4. I want to change this as 0 and 0. Okay, you can also put everything as 0 if you wish, because see here I will be telling you why I am putting everything as 0. Okay, so here you can initialize everything as 0. So I'll be telling you why I am initializing everything as 0. Just a minute. Let me finish the loop. Okay, now here what I'm going to do is, first of all, writing this line, if flag is equal to 0, then what should I do? I want to do this, right? So catchy of I and flag, right, as it is equal to max of minus nums of I plus. So it is what? It is a recursion call. Whenever you find out a recursion call, don't do a recursion call. Just go to the memorization array. Which means catchy of what are the varying parameter I plus 1, and another varying parameter is flag toggle. toggle the flag value, right? Similarly, comma, next value, it is also a recursion, right? So do again catchy of I plus 1 and flag. That's it. That's it. Can you understand this? Similarly, put the next value else. For this value also, for this line also, do the same thing we have done here. Okay. At last, what should I return? At last, what should I return? That's going to the next case, right? I have did everything here. At last, after this entire for loop, what should I return? So that's going to be the next thing, right? So here, what I'm returning 0, 1. Return that's itself. So catchy of 0 and 1. That's it. Can I understand now? Understand up to this, right? Now, I will telling you why I am using this zeros and zeros. See here. Here one of the computation is there. I end flag. Okay. In this two things, whether I have used I end flag again, no, which means I am just updating this value. I am not adding anything or I am not subtracting anything. I am just updating it. So base condition is returning 0. That's the reason why I am putting 0, 0 here. Apart from this, these all things, you can put any values you want. You don't want to initialize any values also. That's your wish. But here I am just initializing everything as 0. Okay. Now tell me what's the time complexity and space complexity. So time complexity will be O of n and space complexity also O of n. But the space complexity is because of the matrix we have used. Okay. So let me show you the code so that it will be more clear. So see here. So this is going to your code. So first of all, our array is modified like what? I have initialized everything as 0 and modified the dimension as from n to n plus 1. That's it. Okay. Now, so always do in a reverse fashion. Here also in reverse fashion. Now, if flag is equal to 0, then what should I do? I will be doing this line. Whenever there is a recursion call, just make that recursion call into a DP array. So this catchy array. Okay. And make the varying parameter as a index. That's it. Okay. So same thing done here also. At last, what should I return? Here I am returning a recursion call of 0, 1. So here I am returning the the DP arrays 0 and 1 in this. Can I understand up to this? Right. Now let me take this. The next method we are getting into, or the next approach of optimization we are getting into, is space optimization. So from the word itself, you can understand we are going to optimize the space, right? Okay, let me write here space optimization. So what I'm supposed to do here is I want to check whether I want this entire matrix or whether I want only one single array. Can you understand this? Okay. Fine. So let me check here. See in this inner loop. Like at this particular point, I want catchy of I and flag. Here I want catchy of I plus 1 and something. And here also I want catchy of I plus 1. Here also I want only catchy of I plus 1, and here also I want only I, which means I only want two rows. One is the current row, one is the next row. Can I understand this? So I can easily modify like I want only two rows of two columns 0, 1, 0, 1, or you can take as current and next. So for this current I need only two columns, and for this next I want only a length of 2. So here I only want these two things. Apart from that I don't want anything, right? Can I understand this? I want only current and the next row only. I don't want any other rows. That's the reason I'm putting here like that. Okay, fine. Now, see what are the modifications I want to do in the code. So see here. Whenever, so at this particular point, I have made these two things. Okay, understand that. Okay. Now, whenever we are using catchy of I want to replace as current catchy of I. Whenever we are using catchy of I plus 1, I want to make this as next. Okay, which means at this particular point I want to replace this as current. At this point I want to replace this as next. At this point, I want to replace this as next. Hope you understand this. Similarly, here also I want to replace this as current. Here also I want to replace this as next, and here also I want to replace as next. Easy, right? Easy, right? Now at last, after finishing this entire loop, after finishing this entire inner loop, I want to swap them. Like, sorry, not swap, I want to initialize the next to the current. Okay, so next is equal to current, which means I am storing this current value into the next for the next iteration. Can you understand this? So if I want to tell you this in this array, watch me clearly. Follow the white color. So see here, at first I'll be taking only this row as a current, and this row, at first I will be taking this row as a current and this row as a next. Okay, and computed every values and updated in my current. Okay, in next iteration I'll be making this as next and this as current. Then I have computed everything in this current, and in next iteration I'll be making this as next and this as current, and in next operation I'll be making these two things. Can I understand this? I don't want everything, I only want two rows, that's it. So that's the whole thing here. Can I understand up to this? Right. Okay, so that's it. At last in this catchy, I want to just return what? Return current of 1. That's it. So when I'm going for the code, you can understand this clearly, but still I am just telling you how we are going to convert each and every approaches further up to we are getting an optimized version. That's the core that's a core thing I want you to let you know. Okay, so what is the time complexity? It is O of n, but space complexity is O of 1, because I am only using what? I am only using two arrays of size 2. So it is a constant space. It's a constant space. That's it. Okay, now let me show you the code so that you can understand this space optimization version clearly. So see here, so this is going to be a space optimized version. So instead of catchy, I have taken next and current. Okay, and then everything is similar. Wherever it is catchy of I replace as current. Wherever it is catchy of I plus 1, I replace as next. That's it. Okay, and after finishing this inner loop entirely, I want to update every current value into the next value for the next iteration. Okay, and at last I'll be returning the currents first in this. That's it. Okay, so this is going to be your space optimization version, and instead of this we can also replace like this also. So see here, so current and next, instead of putting this for if condition. So this if condition is basically like what it is telling, like if flag is equal to 0, then I want to do this. If flag is equal to 1, then I want to do this. So these are the two iterations I am doing. So take that inner loop and just put this two lines as it is. Can I understand this? Instead of flag, I just substituted as 0 at first. Then I substituted 1 next. That's it. So you can also put like that. Can I understand this? So we have started from this big recursion and we have solved it in a small looping. Okay, you can also do this in a better way, like you can only use one DP array of size 2 also. Okay, but I don't want to go that level. It is fine, it is also fine. So if you want to go up to that, try by yourself. Okay, that's it. So if you really understood, please like this video and subscribe to my channel, and don't skip any videos in this DP series, because watching all the DP series and practicing every questions, you can easily crack the new DP question. And if you have any doubts or if you figure out any mistakes, just comment below. I'll be just commenting the answers of them. Thank you.